Hello, today we're doing notes on, we're finishing up section 4.3 in the textbooks, and this is on the remainder theorem. So the remainder in synthetic division, in the synthetic division process, has an important interpretation. Okay, so we're going to do a quick proof real quick. Bear with us. When you divide a polynomial f of x by, this is just another function, x minus k, okay, the result is, maybe I'll use this, f of x divided by d of x. It's just another function. And then we're going to get the quotient. Oh, this will be like function by the divisor, right? D for divisor, Q for quotient. And then we're going to have R as your remainder over d of x. Right, so this all this means is that we're going to take something, divide it by the divisor. If you have a remainder, you write it over the same thing. Q is your quotient, and R is your remainder. So let's mess around with this a little bit and see what happens. So instead of writing d of x as your divisor, let's pretend that d of x represents x minus k, and k can be any number. Okay, so we're going to do f of x, but instead of d of x, we're going to replace that with x minus k equals q of x, nothing has changed, plus your remainder is still something, some function, divided by x minus k. Okay, so not much has changed. It's just that we've put something in there. Now let's imagine that we solve for f of x. Okay, so if we want to get f of x by itself, right now you guys don't know y yet, but let's imagine. So that means I'm gonna, how can I write this without showing that I did it? Let me see if I have a different color. Sorry guys, give me a second. Let's imagine I have, oh here, light blue. So my next step is x minus k, which cancels, right? But here's the thing, when we cancel like this side, we have to distribute to both, right? So it goes to this and this. Okay, sorry, it's a little light. I just need to specify that that was something different. So that cancels out this, right? So the whole purpose of it was to get f of x by itself, and then we'll have q of x times x minus k plus r of x. Okay, so what the heck is the purpose of this so far? Still looks like a bit of a mess. Now, let's keep going with our assumption. Since we know that the remainder equals to 0 or has to be a degree less than x, right? When we use synthetic division, the degree goes down by 1. Then you know that r of x must be a linear function. Oh, sorry, not linear, a constant function. Apologies. That's totally different. Function, which is just any real number. Right, so if I had like x minus 5, then my remainder must be less than 1 degree less than x minus 5. Okay, so this is going to be a number. So then r of x, instead of calling it a function, we just can call it r, which is just any number. Okay, so now then we can keep going. Let's then evaluate f of x when x equals k. Now, what's the point of doing this? We know that k is a 0, or the solution of your divisor, right? If you had something like, let's say, let's prove it to you guys. Let's say like down here, I could rewrite, like if I had f of x divided by like x minus 2, right? That's really saying that x equals positive 2 on the bottom, right? So 2 minus 2 is like 0 if we're setting it equal to 0. So we're looking for a 0 of the divisor. So let's do this then. We're going to have f of and we're going to replace x with k. And we're going to see what happens when we do this. Okay, this is like one of those, like, let's see what happens. So now we have, oh, I just wrote it weird. Okay, so now we have, let's see, this is still q of x right here, sorry, times x minus k, but instead of x, we're going to plug in k, right? That's what we're saying right here. And then we'll bring down the minus k that was there to start, plus r. So instead of r of x, we're going to call it r. Okay, well, you know that k minus k equals 0. And anything times 0 is 0. Right, so this is going to be q times 0. So this is all right here, 0. So what that comes out to is that f of k equals r. And what this means is that when you divide by x minus k, then the remainder is f of k. So the remainder is the same as what you get when you plug in k. Now, what was k? K is the 0 of the denominator. So the remainder theorem tells you that synthetic division can be used to evaluate a polynomial function. Okay, so when we evaluate, say like here, we could take x equals -4 and plug it in, but the remainder theorem says that you can evaluate f of -4 by just finding the remainder when you're dividing by x plus 4. Okay, so evaluate when f of x when x equals k, use synthetic division. And the remainder will be f of k. Oh, I should say to divide f of x by x minus h. Okay, so let's show you what this all means, and then we can practice it. Okay, so this is what we did before. Evaluate by plugging in x equals to -4. So I'm just going to take f of -4 equals to 5, and then everywhere I see an x, I'm going to use parentheses. Oh, sorry, minus -4 squared plus 13 times -4. And you guys see how it's getting pretty tedious. Plus 29. Okay. Well, this is 5 times 5 times -4, -4, -4, and then this is -1 times -4, -4, right? So just so you guys know that this is going to be a negative number. It's going to be 64 times 5. It's going to be -320. And then this will be a negative again, 16. Okay, so you can check your signs. Hopefully you're following along. Right, -320, -1 times -4, -16. 13 times -4 is -52. And then plus 29. And then I'm just going to calculate all of that. -320 minus 16 minus 52 plus 29. And we get f of -4 equals -359. Okay, there were a lot of places for you to mess up there. Okay, so now let's use synthetic division, and it should take less space. So we're going to do this and set it up using synthetic division. So we have x cubes, x squareds, x's, and then numbers. And I always write that in just to like not to mess up. This right here, negative 4, means x equals negative 4. So that's what we're going to write out here. Okay? And then we'll fill in our coefficients. We have 5, negative 1, 13, and 29. So let's walk through the steps. Ready? You bring down the 5. 5 times negative 4 is negative 20. Combine like terms, that's negative 21. 21 times 4 is 84. I didn't use negatives because negative times a negative is a positive. Plus 13 times negative 4. And then plus 29. Do you guys see how I didn't retype my answer every time? Okay, so that's negative 359. And look, our answers match. Right, so if you use synthetic division, there's less places of mistakes because you're just multiplying like 2 numbers at a time versus here you're multiplying like 4 or 5. And we get the same answer. F of negative 4 equals negative 359. Okay, at this point, I want you to turn your paper over and please practice these 4 problems. I'm not even going to give you your answer key because you can check it in the back of your textbook. So it's section 4.3, page 178. This is where the problems come from. This is number 25, 27, 29, and 31. Go check your answers. Make sure you know what you're doing.